Hi, this is Stephanie Conklin. I'm a teacher from New York, and I'm here to talk to you today about a circles lesson called Inside Arcs and Angles. Students will begin this lesson by doing a quick do now to review how to find inscribed angles and the relationship between arcs. After that, teachers can go through objective and agenda for today and hopefully jump right into the first exploration for today's lesson. I'm going to move the camera just so that we can look at the class notes, which you can find online as well. In our first exploration, students are asked to look at this picture, and it's really important to point out to students why is this picture different than the do now questions, the questions we've learned in the past. And this is a great chance to connect some vocabulary. So we have a line here, DE, which goes on forever and just touches at point B, so hopefully students will see this as a tangent line, and it's connected to a chord AB. And from that we have two angles formed. We actually have two arcs, a major arc and a minor arc that's formed. So we've just packed in a lot of great vocabulary to start class off right away. So I usually ask students to go ahead and find these two angle measures, and we're going to find that one of these angles is 40 and the other is 140. And then students can work with their partners to talk through questions 3 and 4, and they want to think about how ABE is related, the angle is related to the arc. So hopefully students will see that we have a 40-degree angle here, and the arc is 80. And then we have a similar idea here that this angle, ABD, is 140, and our arc all the way around is twice that, 280, which students can get 280 because we know the whole circle is 360. And so we're going to ask students to write a rule to determine how to find these inside angles that are formed by tangent lines and chords. And we're really hoping what students won't be able to explain in words or explain in a formula is that we'll take the arc, we'll look at an arc that is intercepted by an angle, and we'll take half that measure. So that's our goal really, to get students for number 4, and hopefully if students are working together they can get this on their own. A really important idea that I want to talk through briefly is how we can get students to see the bigger picture here. Well, we have a line that's crossing or cutting right through at one point, a tangent line, and we know that all lines measure 180 degrees. We also know that all circles measure 360 degrees. And this is a great time for teachers to pause and say, it's interesting that circles are 360 and lines are 180. Does anyone think that a relationship exists between what we just found, that this angle here is going to be 1/2 the arc, and the idea that we have a line that's 180 degrees? So this is an important moment for students to really make a connection between a prior idea, lines are supplementary and measure 180 degrees, straight lines, and also that circles measure 360.